Hi, and welcome to 6.4, solving trig equations using identities. So the identities that we're going to be using are those ones in your formula sheet. So the first question, example number 1, is solve sine 2 theta equals sine theta over the interval 0 to 2 pi. And you'll notice that with the hard brackets, the square brackets, that includes 0 and includes 2 pi. All right, so I guess the first thing is we look up that sine 2 theta in the formula sheet, and we would get 2 times the sine of theta times the cos of theta. And that's going to be equal to the sine of theta. Now, I got to give some caution here. I think the next step that a lot of people would like to do is to divide both sides by sine theta. I'm going to just avoid that for a minute, and then I'm going to try that, and then we'll see what the difference is. So a little bit later, I'll go over here and I'll say, if we divide by sine theta, and then we'll talk a little bit about like why we get some different result if we divide by sine theta. So instead of that, what we're going to do is we're going to equate one side to 0. And it's probably simplest if we subtract sine theta from both sides, so that the right-hand side is going to be equal to 0. And the left-hand side will be the sine of 2 theta cos theta minus sine theta. So now I've got two terms on the left. What's common to both of them is that sine theta. So I can factor out the sine theta. And then I get 2 cos theta minus 1 equals 0. So that means that to get that 0, either sine of theta could be equal to 0, or the 2 cos theta minus 1 could be equal to 0. When is sine theta equal to 0? I'll just draw my little unit circle here, and I think, well, it's the y value. It would be here and here. So I'm going to say theta could be equal to, this would be a good time to go and check out the interval. Oh, it's from 0 to 2 pi and includes both 0 and 2 pi because it's that type of a bracket. So in other words, I'll get 0 pi and 2 pi. Okay, looking on the other side over here, I'm going to get 2 cos theta minus 1. So if I solve for this, 2 cos theta equals 1. So cos theta equals a half. I'll just look at that same one. So when cos theta is equal to half, that's up here, and I have to be the positive examples, right? So when cos is a half, then theta could be equal to pi over 3, and the other one would be 5 pi over 3. So those would be all my answers. Okay, so now let's go, I'll switch colors here. So what happens if we just went and said, let's divide both sides by sine theta? So the first thing we would get, if I divide both this left-hand side and the right-hand side, we would get 2 cos theta equals 1. And then I guess I could divide both sides by 2. Cos theta equals a half. And then my solutions, well, that's the same as this, right? So I would get theta is equal to pi over 3, comma 5 pi over 3. So what happens if I do that? Well, I lose this whole section over here, and those part of the solutions are lost. And it's kind of an odd thing that sometimes you think, oh, there's more than one way to solve it. Well, by dividing sine theta by 0, sine theta from both sides, we lose the situation. If I say sine theta is equal to 0 as one of the solutions, when I'm dividing by sine theta, I'm literally dividing by 0. So it's like the reason why weird things happen is because we're dividing by 0, and it's kind of breaking one of those rules of math. So when you're solving these equations, here's the best method: equate one side to 0, and then factor. Don't divide both sides by something. Okay, let's try the next one. Here we got tan theta equals 2 sine theta. There's no double identity in this one. Oh, look at this. We're not going to include 2 pi on the right-hand side. Okay, so sine or tan theta is equal to sine theta over cos theta equals 2 sine theta. And again, just, making sure, just going to repeat this. I don't want to divide both sides by sine theta. So maybe what I'll do is well, first of all, I think I've got a fraction on one side and a non-fraction on the other side. It's kind of nice to not have to work with fractions. So I'm going to multiply each term by the lowest common denominator, which is just cos, because I just have cos theta. So I'm going to multiply the right-hand side by cos theta, and I'm going to multiply the left-hand side by cos theta. What happens? Well, on the left-hand side, my cos thetas cancel each other out, so I'm going to get sine theta. On the right-hand side, I'm going to get 2 sine theta times cos theta. All right, now it's time to equate one side to 0. I think it's probably easiest if I make the left-hand side equal 0. So I'm subtracting sine theta from both sides. So I'll say 2 sine theta times cos theta minus sine theta. Now I have a common term of sine theta on the right-hand side. So I'm going to say 0 equals sine theta times 2 cos theta minus 1. So I have two results from this. I could say that sine theta could be equal to 0, or the other one is 2 cos theta minus 1 could be equal to 0. So doesn't that look very similar? Let me just look over there. Yeah, it looks pretty well exactly the same. So I'm going to get here theta. I'll just copy my answers from there. And maybe I'll be nice and reorder them in smallest to largest. 0, pi over 3, 5 pi over 3, oh no, pi, 5 pi over 3. Now I got to be careful because in the previous solution I included 2 pi, but now I can't because it's just this little thing over there. Okay, so that's 2a. Oh, you know what? I didn't even read the question properly. Part A was determine the non-permissible values, and then part B is to solve it. Okay, so I did part B here, so I will solve A here. So the non-permissible values. So really the non-permissible values, at the very beginning of the unit we talked about non-permissible values. It's looking for occasions where we're going to get a 0 in the denominator. And if I have this tan theta, I need to unpack that. So I'm going to write sine theta over cos theta equals 2 sine theta. So the denominator, the only denominator is there. So really my non-permissible values are going to happen when cos theta is equal to 0. So when is cos theta equals 0? Cos is the x values. I've got a 0, I guess, up there and down there. So this is going to happen. So when theta, so the non-permissible values are when theta is equal to pi over 2 and 3 pi over 2. Okay, so I switched A and B around. Taking a look at example number 3, there's a little bit of a typo here. I think this C here, I'm not sure, that should be an X, just to be consistent with everything else. So it looks really complicated, but I don't think it's that hard. So I'm just gonna, in each case, tan is the same thing as the sine of x over the cos of x times the cos of x times the sine of x. Cotan is equal to the cos of x over the sine of x. And cosecant is equal to 1 over the sine of x minus 1 equals 0. So now I can say, well, this cos and that cos become 1. Sine x over sine x is another version of 1. Sine x over this sine x is another version of 1. So really all I'm left with here is to say that cos x minus 1 equals 0. That means that cos x has to be equal to 1. And when does that happen? That happens right here. So one example is when x is 0. I should go check. Nope, I can't include the 2 pi because it stops right there. So that would be my answer. Okay, looking at part B. Here I've got a double identity and I've got cos of x as well. Okay, so I just went and cut and paste from the formula sheet the 3 versions of the double identity for cos there. And so we have a choice to make about which one would be easiest for us. And I think that the easiest one is this third one. Just thinking ahead, because on the right hand side I've got a term that only uses cos. So even though this one's cos squared, it's going to set us up to have a quadratic, and then we can factor that. If I have either of those other ones, I'm going to have a cos x, and then I'm going to have a sine and sine here. So that's doesn't help us. So let's change this to 2 cos squared x minus 1, and then plus 1 equals cos of x. Oh, the minus 1 plus 1 cancels each other out, so it's actually going to be pretty straightforward. So now I have 2 cos squared x equals the cos of x. Be careful, do not divide both sides by cos. Rather, equate one side to 0. In this case, we're going to do that by subtracting cos x from both sides, and then factoring out that cos of x. So now cos of x, cos of x can be 0, or 2 times the cos of x minus 1 could be equal to 0. When is cos 0? Well, cos is 0, I guess, up here and over here. So those answers would be x could be pi over 2 and 3 pi over 2. On the right hand side, if I add 1 to both sides and then divide by 2, cos x is going to be equal to a half. When is cos equal to a half? I guess over there and over there. So I could say x is equal to pi over 3 and our 5 pi over 3 are familiar answers. All right, so moving on, we just have 2 examples left in this entire unit. So I'm looking at this, I see 1 minus cos squared x equals 3 times the sine of x minus 2. This here jumps out at me as being the same thing. 1 minus cos squared is the same thing as sine squared. So I'm just going to put this in. Sine squared x equals 3 times the sine of x minus 2. So now I can equate one side to 0. So I'm going to get sine squared x minus 3 sine of x plus 2 equals 0. So, you know, for some people, they can just look at that and factor it with sine of x. For others, sometimes it's helpful to do something like this. Say, let a equal the sine of x. And then when I'm thinking about this, it looks like a squared minus 3a plus 2 equals 0. So now I need two numbers that multiply out to positive 2 and add to negative 3. So I think it'd be negative 2 and negative 1. Don't forget to put that 0 over there. I think it's a good time now to switch back to say, okay, that means that the sine of x minus 2 equals 0, or the sine of x minus 1 equals 0. So in here, I'm going to get sine of x equals 2. Here I'm going to get the sine of x equals 1. If I do the unit circle, I'm thinking, okay, on the unit circle, sine is the y value. You can never get up to 2. Like the largest it gets is 1. So this is going to be an example of no solution. And over here for sine of x is equal to 1, here I'm going to get x is equal to 0. I think we're still doing, we're still doing that same. We can't include 2 pi, so I won't do 2 pi on that one. Okay, here's our very last question. This is actually a good one to do. I'm glad we're doing an example like this because this pops up every once in a while. So just remember that cosecant is the same thing as 1 over the sine of x. So what we're going to do to start off is, again, we've got a fraction here. Maybe I'll rewrite it to begin with. I'll get 2 times the sine of x equals 7 minus 3 times 1 over sine of x. So I'll write it like that. So what I'm going to do is multiply both sides by the sine of x. I'll just erase my mess over here. So in that way, I'm not going to have any fractions. Now, I think what a lot of people forget to do is, like, when we multiply this side, I need to multiply each of those terms by the sine of x. So on the left-hand side, I'm going to have 2 times the sine squared of x is equal to, so 7 times the sine of x. So I can say 7 times the sine of x minus 3, because 3 over sine of x times sine of x, those cancel each other out. Now we're almost there. I think you might be able to see what's next. Old familiar one here. So I'm going to equate one side to 0. So I'll get 2 times the sine squared of x minus 7 times the sine of x plus 3 equals 0. I think now I need two numbers that multiply out to 2 times 3, that multiply out to 6, and that add up to -7. Well, they're going to have to both be negative. So -6 and -1 will work, right? -6 plus -1 is -7. Yeah, that'll work. Okay, so this is going to turn into a -6 and a -1. So when I write it all out, I'll have 2 times sine squared x minus 6 sine of x minus the sine of x plus 3. Now when I group the first two terms together, these two terms together, I'm looking at this and I see not only a common factor of sine of x, but also 2. So I'm going to put 2 times the sine of x times the sine of x minus 6 divided by 2 is 3. Okay, minus, okay, so there's nothing in common here, so I'm going to put a 1 here, and when I factor out a -1, here I'm going to get a sine of x minus 3. And then I'm really happy because I've got these two that are the same. So now I'm going to factor out a common sine x minus 3 here. So I'm going to get sine of x minus 3. When I factor it out of the first term, I get 2 times the sine of x. And when I factor it out of that second one, I get -1. Oh, you know what? I have been a little remiss here just looking at this stuff. I'm going to, again, clean up my mess here. I forgot the equal zeros. So put those equal zeros in there. Okay, so from that sine of x equals -3, then I would say that means that the sine of x equals 3 is one way to get that 0. But I'm never going to get a 3, so that's a no solution there. And then 2 times the sine of x would be equal to 1, so the sine of x would be equal to 1/2. So sine of x is equal to 1/2. I guess that's over here, and over here that's a pi over 6 and a 5 pi over 6. So my two answers, those are both within the domain, be x equals pi over 6, comma 5 pi over 6. All right, and those are some suggested homework questions, and there's also the reviews that I've prepared for you from the old provincial exam questions. Excellent. Well, I'll see you guys in class.